Welcome to the Mind Spark, bringing you the latest news from around the world. The universe is full of wonders and monsters. Out in the vast, silent reaches of space, there are forces and objects so powerful, so mysterious, that they defy our imagination. These cosmic beasts lurk in the darkness, shaping galaxies and rewriting the rules of reality itself. The biggest of all, black holes. These are the true titans of the cosmos, lurking at the hearts of galaxies and sometimes wandering alone through interstellar space. Think of them as cosmic prisons, points in space with gravity so intense that nothing, not even light, can escape. Their pull is absolute, warping the very fabric of space-time around them and creating a region from which there is no return. Cross the event horizon, and you're gone, pulled into a singularity, a point of infinite density where the known laws of physics simply break down. Here, matter is stretched and compressed in unimaginable ways, a process scientists call spaghettification. Black holes are born from the violent deaths of massive stars, collapsing under their own weight and punching holes in space-time. When a star runs out of fuel, it explodes in a supernova, and if it's massive enough, its core collapses into a black hole, a cosmic wound that never heals. We can't see them directly, they swallow all light, but we know they're there by the chaos they cause. Stars shredded, gas heated to millions of degrees, and matter swirling at incredible speeds before vanishing forever. Their presence is revealed by the violence they unleash on their surroundings. For decades, we believed black holes were the universe's final punctuation mark, where the laws of physics break down and information is lost forever. They were thought to be the ultimate cosmic endpoints, erasing everything that crossed their threshold. Einstein's general relativity described them as silent, inescapable voids. Things go in but never come out. The event horizon was a one-way door, sealing away all secrets. It seemed like a law written in stone, unbreakable and absolute. But the universe loves a plot twist. Just when we think we've figured out its rules, it surprises us with something new and astonishing. Just when we think we understand, it throws us a curveball, challenging our deepest assumptions and forcing us to rethink what we know. One day, while observing a distant galaxy, humanity's most powerful telescope saw something impossible, a discovery that would shake the foundations of astrophysics. Something was coming out of the darkness. Against all expectations, energy and matter were being ejected from the very heart of the black hole's domain, emerging from the very place defined by its inability to let anything go. It was as if the black hole itself was breaking its own rules. The monster wasn't just feeding, it was speaking. It was sending out powerful signals, jets of energy, and perhaps even information across the cosmos. For the first time, the cosmic prison seemed to have a message. The rules had changed, and the universe was telling us to look closer, to question everything we thought we knew, and the universe was about to reveal a new secret. In the darkness, a new chapter was beginning, one that would challenge our understanding of reality itself. Enter the James Webb Space Telescope, our golden eye on the cosmos, a marvel of human engineering and ambition, designed to peer deeper into the universe than ever before. Floating 1,000,000 miles from Earth, far beyond the reach of our planet's shadow, Webb orbits in silent vigil, its mirrors open to the cold, endless dark. Designed to see in infrared, Webb peers through cosmic dust to the universe's earliest moments, revealing stars and galaxies that have been hidden for billions of years, painting a picture of cosmic history. But on this day, it found something else, something unexpected. A supermassive black hole, millions of times the mass of our sun, flashing with a strange, repeating light, unlike anything seen before. Not the chaotic, unpredictable flares we've seen in the past. This was a pulse, regular and precise, like a cosmic metronome keeping perfect time in the darkness. The science team suspected a glitch, a malfunction in the instruments, but every test came back clean. The signal was real, undeniable, and persistent. It came from the very edge of the black hole's event horizon, the point of no return, where gravity is so strong that not even light can escape. Not the messy noise of matter being consumed, but a clean, repeating pattern, a beacon, as if the black hole itself was sending out a deliberate signal, a message in a bottle from the abyss, drifting across the cosmic ocean, waiting for someone to notice. The implications were staggering. If nothing escapes a black hole, what was this? How could a signal emerge from a place where the laws of physics say nothing should return? It was as if the deepest trench in the ocean was sending out a clear, steady drumbeat, an impossible rhythm from the most unreachable depths. The universe had presented us with a paradox, a phenomenon that shouldn't exist, a riddle written in light and gravity. The abyss was talking, and for the first time we were listening, straining to decode its message. Scientists scrambled to make sense of it, poring over data, running simulations, and debating late into the night. Was it a new kind of flare, a cosmic accident, or something more? Perhaps a new law of physics, or even a sign of intelligence. The signal's regularity suggested intent, or at least order, a pattern that defied the chaos we expected from such a violent place. The astronomical community was stunned. News of the discovery spread quickly, igniting curiosity and debate around the world. The rules of black holes were being rewritten in real time, as if the universe itself was challenging us to understand more. The mystery deepened with every pulse, each one raising more questions than answers, drawing us further into the unknown. And the search for answers had just begun, as humanity turned its gaze to the abyss, determined to uncover the secrets it was finally willing to share. To truly grasp how shocking this discovery is, we need to step back and consider the fundamental rules that govern our universe. Remember what a black hole is, a bottomless pit in space-time, where gravity is so overwhelmingly strong that not even light, the fastest thing in the universe, can escape its pull. According to Einstein's general relativity, the event horizon marks the ultimate boundary, the point of no return for anything that crosses it. At this edge, the escape velocity is greater than the speed of light itself, which means nothing, no matter, no energy, not even information, can get out once it's crossed over. This isn't just a wild theory, it's a cornerstone of modern physics, tested and confirmed by decades of observation and experiment. That's why the appearance of a structured pulse from a black hole is so utterly baffling. It seems to directly contradict everything we thought we knew. The laws of physics say that any information falling into a black hole is lost forever, erased from our universe with no hope of recovery. Yet here was a signal, not only escaping the black hole's grasp, but carrying a clear, organized pattern, a form of information that shouldn't exist outside. Are the laws of physics themselves wrong, or are they simply incomplete, missing some deeper truth about the universe? When science encounters the impossible, it's not a dead end. It's an invitation to explore, to question, and to learn something entirely new. This mysterious pulse is a clue, a hint that there's a deeper, hidden reality inside black holes, one that we're only beginning to glimpse. The so-called unbreakable law has been shattered, and now, the quest begins to understand how and what it means for our understanding of the cosmos. How did we see this impossible event? Credit goes to the James Webb Space Telescope. Unlike Hubble, Webb sees in infrared, peering through cosmic dust to the hearts of galaxies. Its giant gold-coated mirror and frigid temperature let it detect the faintest whispers of light. Webb's sharp vision isolated the repeating flash, something lesser telescopes would have missed. Its advanced instruments break down the light, revealing clues about its source. Webb didn't just spot the impossible, it gave us the tools to investigate it, the perfect instrument at the perfect time. Normally, black holes are surrounded by chaos, swirling accretion disks, violent flares from shredded stars. These flares are messy, random, and unpredictable, pure cosmic mayhem. But the Webb pulse was the opposite, structured, rhythmic, precise. Imagine the difference between a building collapse and a perfectly timed drum solo. The new pulse flashed with unwavering regularity, its spectrum clean and orderly. It didn't fit any known model of black hole behavior. Scientists were stumped and excited. The orderliness suggested something was controlling the output. This wasn't just matter falling in, it was a signal that defied the expected chaos. New physics might be at play. When the laws of physics break, it's time to think outside the box. Scientists considered wild ideas, serious hypotheses from quantum mechanics to science fiction. Could this be a magnified, structured version of Hawking radiation, or a white hole, the theoretical opposite of a black hole, pouring matter and light out? Maybe a wormhole connecting to another universe? And then, the most tantalizing idea, could the signal be artificial? Evidence of extraterrestrial intelligence? A repeating, structured signal is exactly what SETI searches for. Of course, the simplest explanation is likely natural, but every theory is on the table. The only certainty, we've stumbled on a profound mystery. The race to solve it is on. Webb's discovery ignited a global scientific collaboration. Observatories worldwide reprioritized, aiming every instrument at the mysterious black hole. Teams coordinated across continents, from Chile's observatories to space-based X-ray telescopes. Data poured in, building a multi-wavelength picture richer than any single telescope could provide. Theoretical physicists published new models, and online forums buzzed with debate. The problem was so new, every idea mattered, graduate students and Nobel laureates alike. Engineers fast-tracked upgrades to detectors, and new software linked observatories in real time. A planetary-scale telescope was born, watching the black holes every beat. The world's scientists united, turning a baffling discovery into a shared quest. This is science at its best: curiosity, collaboration, and wonder. The search for answers continues, stronger than ever. What does it all mean? We stand on the brink of a revolution in our understanding of the universe. This single, repeating flash could rewrite our textbooks on gravity, cosmology, and the nature of space and time. If it's a new quantum phenomenon, it could unite relativity and quantum mechanics. If it's a wormhole, it could reveal shortcuts through the cosmos or even gateways to other universes. If it's a signal from intelligence, it would change humanity forever. Every new observation is a clue in this cosmic detective story. The universe is challenging us to be smarter, more creative, and more curious. The journey into the unknown continues, and the future of discovery has never looked brighter.